All right, let's hit chapter 2. So section 2.1 with functions. So we've got a little bit of vocabulary to go through first. So a relation, in mathematical terms, is a correspondence between two sets. So there's some sort of relationship between this set and this set, or set. Usually a relationship between like x's and y's. So a function, which is what we normally use and talk about, it's a relation where every input has one output. So if you plug a number into the function, you're gonna always get a result. But what tells you what you can plug in is the domain. So these are the values that you plug into, or that you're allowed to plug into the function. And this is typically the x, or the input values. And the range, these are the y values. These are what you get as your answer. So these are the output values. So function notation, like you've all seen it, you've all used it. So they're often denoted by letters such as F and G, upper and lowercase, and others. So if F is a function, then for each number x in its domain, the corresponding y value in the range is designated by the symbol f of x. So this is the function notation, read as f of x. And we refer to f of x as the value of f at the number x. So again, just a little thing to denote because sometimes people forget. F of x does not mean f times x. It's one of those things where you got to realize what you're looking at to know what they're talking about. So yeah, we're using parentheses here, and they teach you in arithmetic, hey, when you've got something next to parentheses, it's multiplication. Well, not in this case. It changes depending on what you're talking about. Okay. So example 1, we're going to lock this function in at x squared minus 3x plus 1, and we're going to evaluate each of the following. So again, this should not be new. You're going to take whatever is inside the parentheses, and you're going to plug it in and substitute it in there for all the x's. So that would knock out this term and this term since it's a 0, and you're left with 1. If we were in class, I would totally give you time to go through all of these, and then we'd all talk about them and compare our answers, but since no one's here, we're just going to do them. Okay, plug in the 4. Replace all or substitute all the x's with a 4. So 4 squared minus 3 times 4 plus 1. And if you work that out, 16 minus 12 plus 1, that's 5. Okay, now just be a little careful when you're plugging in the negatives. When you do that, you want to put parentheses around a negative number so that way the operation stays with the entire number and not just parts of it, especially with powers. Okay, so that will complete it. So you end up with 1 plus 3 plus 1, and you end up with 5 again. Okay, so if you went through the rest of these, if you plugged in the root 3, this one doesn't simplify down to a whole number or one number even. We end up with a quantity. 4 minus 3 root 3, which can happen. You don't always have to get a nice number out of these. They can be a little off, a little crazy. So you can get positives, negatives, whole numbers, fractions, radicals, things with pi in them, all sorts of stuff. All right, moving on, part E, f of 3. And then when you get your answer, you're going to square root it. So order of operations is still the boss. You still have to follow the order it sets forth. So you got to do whatever is on the inside first, and then outside part is last. So f of 3, if you plug in the 3, you get 1. Square root of 1 is 1. Okay, so we're going to skip F and G. Let's go into H. I'm going to plug in the N, and like, don't panic because it's not a number. It's like, it doesn't matter what it is. If it's inside the parentheses, you still got to plug it in and work it out. So if you plug in an N, we end up with N squared minus 3N plus 1. And that's all you can do with it. It didn't tell you to factor, it didn't tell you to solve it. Just plug in the number or the letter or the quantity, and there you go. Okay, so let's skip I and go straight to J. Now for J, you're plugging in the 2x. So it would look like this. And then if you squared the term, multiplied, 4x squared minus 6x plus 1. Okay. Now K, all you're doing here is you're just multiplying the function by 2. For L, you're just going to add 1 to the function. So x squared minus 3x plus 2. Now for M, you're taking the entire quantity of x plus 1, and you got to plug it in for every x. So that would be x plus 1 squared minus 3 times x plus 1 plus 1. And then you got to work it out. So if you squared everything in this quantity right here, if you FOILed that out, that'd be x squared plus 2x plus 1. And then if you distribute, minus 3x minus 3 plus 1. And then combine your like terms, we end up with x squared minus x plus 2. Okay, so it's not, again, it's not something that you don't know how to do. It's just sometimes it can be a little tedious and a little tricky if you're not being careful with it. Okay, so this right here where it says example 2, find the domain of each function. The formatting got away from me on this, and so it's really talking about the functions on the next page. So I'm going to stop the video here, and then we'll do that in the next one.